we're going to get started. My name is Jake Wharton, and I work at Cash App.
Hey everyone, I'm Sumayyah and I work at Square.
So we have a panel here of 4 people who all are in or around dependency injection libraries and frameworks, and we're going to ask them some softball questions and some heaters, and we're going to let each one of them introduce themselves down the line here. So Zach, kick us off.
Hi, my name is Zach. I work at Slack.
And maybe what your relation to dependency injection frameworks is, why you're up here. Why should we trust you?
I have worked a bunch on some projects you might be familiar with, like Anvil and a newer one that I published earlier this year called Metro.
My name is Bridget Phillips. We're shipping that in prod right now. So I work at Cash App. My relationship to dependency injection is that I've been working for like a year and a half on kind of shifting and untangling our dependency graph at Cash App. And in the process of doing that, I developed some strong opinions. And I think we chatted a bit about those strong opinions as you were working on Metro and also with Jacob and Jesse as we were thinking about this whole Anvil Dagger Metro thing as it was happening. So, yeah.
I'm Jacob. I work at Square. I spend most of my time maintaining the DI graph. I started recently trying to port Anvil to K2 with other folks, and it was hard. And then Zach released Metro, so now we're trying to rally around that and use that as our K2 solution.
I'm Jesse Wilson, and when I started at Square, they said, our application doesn't start fast enough. Optimize juice, and Dagger was born.
All right, so I'm going to start off somewhat easy here. At what point should we really start teaching dependency injection to people who are either new to Android development, new to sort of your company and your architecture, and how do you even do that without sort of drowning them in complexity and despair?
Despair. I think that like it's like, you know, addition, subtraction, spelling, dependency injection. If we start them early, I think that the biggest problem is that if we're teaching, it might be teach dependency injection, not dependency injection frameworks. I think that like dependency injection principle is not that complicated, but I might be biased.
I agree 100% with that. Dependency injection, the pattern is table stakes. The frameworks and the way our frameworks integrate into the app, I kind of am of the personal opinion that hopefully you've built your app such that most people don't need to care about it. That's probably not the way it works for every company, but I kind of like, I prefer it a lot if you don't have to think about Dagger, don't have to think about Anvil, except when you're like, you know, writing contributes module or something like that, right? Like when you're publishing your dependency. Other than that, hopefully you shouldn't have to think about it too much. If you are, I think that is, I would always rather a new engineer be thinking about solving problems for customers, and DI is always like one off from that.
Having worked at a smaller startup before, if you want a really practical guideline, it might be when you start writing tests. Or maybe that's a good guideline for when to introduce a library.
So never?
Depends on the startup.
All right, so here's another semi-easy question, but I invite you to give your opinions. So what are the strengths and weaknesses of the current DI framework, and how should teams choose the right one for architecture and scale? And Zach is not allowed to say Metro because he built it. You have to have opinions about everything.
So I'll say Metro since Zach can't. But yeah, it is a good solution if you have a large project because it compiles quickly. There's a lot of work going into that, done by a lot of people. Anvil was like a tool that existed to make it faster before, but it doesn't. Or Anvil KSP came, and that is K2 compatible, but it's not as performant. So, yeah, build speeds are a big problem at scale.
I just want to mention that Jesse has built more DI frameworks than I have.
One, two. So I think that what we're all waiting for is somebody to have an opinion on DI frameworks versus DI-like frameworks. And I will announce to the world I am a DI-like framework hater. And the difference between what I call a DI framework and a DI-like framework is that if you find out that you've got a dependency missing at runtime, it's not dependency injection. It needs to be compiler enforced. And so I think that that's the biggest distinction. If I say you built a service locator and not a dependency injector, that's a very mean diss, because the service locator fails when you try to look something up and it says you forgot to hook that up, and I don't want that.
I'll say I think this is a really rough question for us to answer, because I don't think any of us are really doing a lot of greenfield application development. Maybe Zach, you in the process of working on Metro, has kind of bit at that a bit more. But I don't know. I guess y'all for your server-side work have had to think about things like Kotlin Inject and other alternative frameworks. But I don't know. To me, if I'm thinking about when and what DI framework to use, the first important thing is to choose something early on, because the biggest long-term impact that a DI framework has on your app is how it grows and how your classes relate to one another. And that impact on your design can be really hard to unwind. I've seen that in code bases that don't have DI frameworks. Other than that, I think that Kotlin Inject is a great option, and there's now Kotlin Inject Anvil. It's also a great option. If you're doing KMP, you need to be thinking about what is compatible for that. And honestly, I think that now Metro is a great option that is really performant. And so I don't know. I wish I had a stronger opinion. That's kind of where I'm at.
So you're kind of leading into what the next question was supposed to be about, which is it's a somewhat tumultuous time in the dependency injection space in Kotlin. And so should we be building stuff in a way that is set up so that we can be migrating to these libraries? Or is it that we go all in on, Dagger 2 in the most vanilla Dagger 2 way, and then if we need to change, we just end up paying that cost when it happens? Or should we kind of be upfronting a little bit of that and architecting in a way that we're somewhat agnostic to our chosen library?
I think a lot of that actually can be solved by the maintainers of those libraries. At the end of the day, a dependency injection as a pattern, I don't think changes that much across different libraries or frameworks you might use for it. And being able to, I guess the JSR 330, the spec for that is supposed to be interchangeable, or you can maybe add your own extensions to it, but the core principles are supposed to be intelligible to different frameworks. And so I think that makes it easier to take a dive into one and know that even if you move to another one, a lot of it is gonna be interchangeable. And a good library, I think, can also make it possible to use different annotations. So Dagger supports this with Java X and Jakarta annotations. Metro and Anvil KSP allow you to bring your own annotations for things. And those are usually the primary entry points for these. So I don't think it's a huge issue.
There's a few things that don't use JSR 330, and I don't think JSR 330 is sort of complete enough to switch between them. But if you're using something that's sort of in that space, Metro or Dagger or Kotlin Inject, switching between them is super awful and unpleasant, but doable in a way that, like, if you switch from coin, I think that's going to be much more difficult.
Yeah, I think that's the case. I think that if you're at a medium to large size company, it's going to be a really heavy lift to say I should maintain my code thinking that I'm going to move to another dependency injection framework. Because like at Square, at Cache, we're already in the weeds of thinking, like, I know that there are ways in which the compile artifacts have been designed such that they perform well with a specific DI framework. And once you're in the weeds like that, and I don't think you shouldn't not be in the weeds. Like your build times are more important than your future flexibility. And I think Zach has it exactly right, that it's really on you as a maintainer of Metro to make it so it's feasible for somebody who's on Dagger 3 or Dagger 2 to migrate over to Metro, rather than like talking down to people and saying, oh, well, you should have designed your code base better so that you could do this in the future.
Yeah, definitely what they were both saying. Our plan at Square is to try and be able to build with both at the same time for a period of time. So everything is being designed to be interoperable. We're trying to add interop features to Metro to make it easy for you to migrate. And if it's not easy enough, tell us.
So all of that sounds like we're at the point where the overriding complexity or the limitations of the DI framework are bringing us to the point where we are considering migrating, right? You go from one framework to another to better meet your needs. But before that happens, how do you detect that this is an actual limitation of the framework and not just of your code? And if it's not a framework limitation, how do you mitigate the complexities that you're running into?
Well, for example, with Dagger 2, you know that capped is taking up your build time. You see 3 minutes capped task. That's clearly a problem with the DI framework. That's where something like Anvil came in to try and solve that problem. And Anvil KSP is currently available as an option in K2, but K2 is forcing us to migrate again. At our scale, with the size of our code base, we need something very fast. So that's what's forcing our hand.
Can I ask a spicier question that I'm not sure is directly related to this? Why couldn't we just have Anvil forever and have it work great the way it has in the past for the future? Why couldn't we just do that? I would, as a user of these libraries, I would say, why would I have to migrate? I would rather just keep on using the thing that I currently used. And I don't know. I kind of know the answer to that a bit, but like I think that's an interesting question that I'd like to raise.
You want it or me?
Go for it.
So there's sort of two parts to this answer. One is the more showstopper answer, and that's that a lot of the way that Anvil 1.0 and 2.0 worked was as a compiler plugin to the K1 compiler. And anyone who's been following Kotlin may have noticed that the K1 compiler was deleted. And that makes it very hard to run a compiler plugin in the K1 compiler for obvious reasons. So what needed to happen was Anvil's compiler plugin would have to move to K2. There were other constraints that came up with that, in that Anvil is inherently, or Anvil 1 and 2 are inherently sort of an extension or a wrapper around Dagger. And it still needs to work with Dagger, which means that it has to be able to run in the, sorry, we're getting in the weeds here, but bear with me. It has to run in the build pipeline in a way that's going to be compatible with Dagger. The way that worked historically was that it ran during the capped stub generation step. Now in K2, say you move everything from the K1 compiler plugin APIs to K2. In K2, only the front end of the compiler is going to run during cap stub generation, and it is not going to allow third-party compiler plugins to run during that step. So once again, you cannot run, you can't rely on a compiler plugin to run in that step of the pipeline. You have to run something either before that, which is where something like Anvil KSP is able to work as a precursor step to capped running, or you get rid of Dagger, which is not exactly a simple task.
You stab it.
The second part of that is that you start having layers and layers of abstractions on top of your DI framework. You know, at some low level you have Dagger, and then you have Anvil. You have KSP running in there somewhere. You have capped running in there somewhere. You can have these all working sort of harmoniously, but at some point you start having to have like build engineers on your team know how all these pieces fit together. And like in the worst case scenario, your individual like feature developers are going to have to know how these fit as well, and they don't really want to know. They don't want to have to know how those fit.
Nobody wants to know what KSP is.
And being able to have, in my opinion, a single cohesive solution that doesn't have all these different steps in the build pipeline that you're trying to orchestrate together is a nice place to be. That's
Also, the question was, I just want to keep using Anvil, and you basically are. You can even leave the Anvil imports there with the interop APIs.
Okay, so all of you work at large companies with large apps. You've mentioned a bunch of very technical details on technologies that are required for running these dependency injection libraries. Or you mentioned build teams. And I suspect a lot of people don't have either that level of scale such that they need massive DI frameworks with and have dedicated build engineering teams. So is dependency injection something, this goes almost back to like the teaching question, but like, and actually let me add in as well, the rise of Kotlin multi-platform and all those technologies that you talked about has made effective use of dependency injection. For all its faults, like Java and annotation processing was a stable thing you could rely on. And so with the desire for us to move to Kotlin and potentially Kotlin multi-platform, where KSP is not really stable, kind of always has to be tracking the compiler. Compiler plugins are guaranteed not stable for years. KAPT only works on JVM or Android. Like, should people in smaller companies that don't have these resources just use a service locator or throw all their dependencies in the application class until they get to this point?
Please, dear God, do not use a service locator. I'm sorry, Jesse, I beat you to it.
We agree.
We agree on this. Cache actually had a service locator in it for like a hot minute, and it was a very small section of the code, and it was a nightmare for me to unwind and move it to something as a compile time. To answer the question, like, really, these tools should not be in a state where you need to have a build team to use them effectively. I think that Anvil had kind of gotten to the place where it helped a lot to have a build team to deal with it, because all the things like that Zach was describing that are very in the weeds that have taken me a lot of time to kind of like parse through in conversation and see the impact to what the actual API is. At a concrete level, for an engineer who's just using the thing, it has meant a lot of smoke flying out of things like incremental compilation, right? That was just really hard to make work reliably because of all these layering things, about having to think about capped around KSP. And suddenly engineers in your company are having to think about this stuff. You don't want them to think about this stuff. You don't want to have a team. And so I'm optimistic that building on this next generation of Kotlin compiler tools is going to wipe out a lot of that stuff, and so that you don't have to think about it that much and everything just works and it's performant. We'll see. I believe in you, Zach.
I believe in you, Zach.
actually want to know, what is a project you can think of that doesn't need DI at all?
Your sample project that you write for your interview. Seriously, I see it all the time, and I'm like, it's way more interesting to see a sample project that uses the dependency injection pattern effectively and has like opinion on how to build itself up that doesn't use Dagger. Like, we kind of know at this point that most people are going to know how to use a dependency injection framework. So interesting to me when I see a sample project come up that doesn't use that stuff.
I think sometimes the overhead of a DI framework can be overstated. It's not actually that much boilerplate. In the case of Metro, make a single annotation on a class, and then you can just start adding @inject all over the place. So generally just always use it, unless it's a very small sandbox.
So we've thrown some nails into service locators. Should we be concerned that Compose UI is leaning a lot on service location through composition locals, or do we need to design dependency injection for composables?
That just hurts my heart. Yeah, composition locals are composition local is a very good branding of a global variable, right?
You want to hear a concrete problem that we just had around composition locals and the issues with them? So Cash App is dealing with a migration right now from Picasso to Coil, right? In our Compose land, we solved the image loader problem with composition locals, right? And so all of our, like, you know, we have like our avatar views or whatever, they implicitly take in some composition local. And as part of our current migration step getting there, we actually have the support for a lot of things that they can load with either Picasso or Coil, but not everything. The problem with composition locals is that you cannot see that at the call site. You cannot see it at compile time. It is a runtime error for that to happen. So what we've had to do is go through this process where we first start by taking every single call site that passes in any image loader and supporting all of them, and then going in and like wiping out all the call sites and only supporting Coil, and then we're gonna like strip them from the composition local providers and all that kind of stuff. But it's not something that you get any help from the compiler when doing, which is not what you get with Dagger or with Metro or Kotlin Inject or any of these tools. They're really high leverage for refactoring scenarios. So that's something that composition locals are neat for some, I think for like themes. I wrote ages ago a blog post about how themes are like a specific case of dependency injection. That is kind of a scenario where it can kind of sort of be great. But I would lean away from using composition locals if you can. I don't know, but there's probably a room for something better there.
How about this? You're allowed to use a composition local if every composition in your application has it, right? So you just say, if every single place I do a composition, I'm going to have an image loader, then you're allowed. And if there would ever be a composition without one, no global variable for you. Like in our code, it's everywhere has a theme, and that works really well.
I don't know. I want to think on that one. It's an interesting question.
I also think that you can just make an architecture so you can still use DI in a class that has a composable in it. So it's also partly just a design pattern of how you structure your code. But there's always room to have new features and better integrations.
Jesse's going to kill me, but I think in UI code, sometimes it just works. And the way that we have set up safeguards for this at Slack has been, we have like a global allow list in our lint configuration for any composition locals. and that file, if someone tries to add to it, pulls in people that can like actually give a stronger review on it, and if that makes sense. The biggest thing that we look for is that it has a sensible default if it's absent. If it's like nullable, then people are naturally going to handle that case at least, gracefully. Maybe they just show like a blank screen or something, but it's not going to crash the app. We don't really use it much for like being able to backdoor in like test dependencies for unit tests. It's really for sort of more pervasive APIs that we want to use and don't want to have to plumb down every time, like an image loader, like our Slack theme, some other things that we use in our like internal design system. And in Compose, that that system kind of just works for us. So I guess maybe that's my answer, is a lint config and have people that talk about it and have a good sense of what the right balance is.
That seems right. Like you're not injecting your clock that way. Perfect.
This is a little bit of a follow-up, but does something like, so Composition Local is like Compose UI library feature, and it stands sort of in contrast to a dependency injection library you choose. What about like the forthcoming context parameter language feature in Kotlin? Where's the balance between leveraging that for declaring dependencies and relying on something like a dependency injection framework?
I keep seeing everybody say that like context receivers are dependency injectors. I don't think they're dependency injectors. I think they're just nicer syntax for passing parameters. And like dependency injection is passing parameters. But like a thing that's very important is that with dependency injection, I do not care what my transitive dependencies are. I only care what my direct dependencies are. So if I inject a image loader and that thing needs a network client, the network client's not my problem. I just, like, everything is local. And I don't think context receivers attempt to solve that problem, and I don't think that that's like a dependency injection thing. That's just like beautiful Kotlin syntax.
What if we use the DI container to solve this problem? Like you could imagine, and I'm just going off the top of my head because what could go wrong? But like you can imagine you've got a function you're calling that declares dependencies via context parameters, and then have some sort of API where you use your DI container to fill those for you. And then you're not passing the parameters all the way up and down the stack.
That does not work.
It won't work.
I mean, it works locally, but the part I want to emphasize is that like, if I accept a context parameter of coil, when I call functions on coil, that object like has its dependencies filled for it already, and therefore, it's not taking its context parameters that way. And like the dependency injection, I don't know, like the whole idea that makes it work is I say I need X and Y, and if X itself needs A and B, that's not my problem. I don't have to think about it. I have to worry about it. And like your example of like somehow magically make it work, I don't think that like would turn out to anything that would make sense syntactically. Maybe a stronger example.
I guess like the idea that I've got in my brain now is like in Compose, we kind of have built out this world where like suddenly function calls act a lot more like instances in an object graph, right? Like, and we've got a DI container that knows how to look up functions look up dependencies by qualifier key. We've got this tool. Can we, do the Apollo 13 thing where we take, the square connector and plug it into the round hole?
No. and the reason that we can't is that in my source code, I say like I depend on a analytics client, and I depend on an interface, but not its implementation. And then at runtime, I have to provide an implementation. And that implementation has its own dependencies. And we can't statically deduce those dependencies. We have to do it either at runtime or with compiler tools. But anything where like my code knows the dependencies of what I'm calling is, it would be very weird if my code failed to compile because something far away didn't correctly set up an analytics client.
Yeah, it would have to be like really deeply wired into your expressions and how they're evaluated.
Okay, we have time for one last question for our panelists before we'll start taking audience questions. So I do want to ask if anyone in the audience has a question, please start lining up at the mic stand and we'll get you a mic. But for our panelists, we just were talking about the what ifs, right? Like, what if we could do things this way? So on that note, are there any Kotlin language features that could be added which would make using DI frameworks easier?
I really like the syntactic sugar of Kotlin constructors, where I can declare a function parameter and a val, and everything sort of happens. Like when we wrote dependency injection in Java, you'd write the field, and you'd write the constructor, and you'd write the constructor parameter, and then you'd assign it. And every dependency was referenced 4 times. And in Kotlin, I reference it once using the same constructor mechanism they already have. So I think that like the thing that I would ask for, we got like 8 years ago.
I need one of your mics for audience questions.
Wait, I have one answer to it. Stabler compiler plugin API would go a long way.
Okay.
All right, so I work at a company that has a different form of DI. So excuse a little ignorance of Dagger.
Sorry, can you talk a little closer to the mic?
Sorry, I work at a company that has a kind of a home-rolled DI. So excuse any ignorance of Dagger syntax or anything for this question. Okay. Hot take, I have a problem with DI as a concept. Obviously, the constructor injection, with constructor injection, you need to build all the dependencies before you can build the thing, even if the dependency is rarely used. The app I work on has tens of thousands of injectable objects. This can cause incredible and non-obvious overhead when building anything. Injecting factories solves this problem, but falls well outside of the funnel of success. I have to know to inject a factory. It's not the obvious thing to do. Ideally, lazy injection would be the default. The advantage of a service locator API is that objects ask for what they need only and exactly when they need them. Is it not possible to have something like a service locator pattern but with the compile time guarantees of a DI system like Dagger?
I think Facebook did something like this ages ago.
Oh no, you caught me.
Yeah, I feel like I used to have stronger opinions about this, and it's left my brain. Do y'all have?
Can't you just use provider or lazy?
Yes, that falls out. You have to know to do it.
Yeah.
Like it assumes that you, a feature engineer, are really considering the performance of the application, specifically the startup performance, at the time that you write your feature.
I think that we should make it so that Metro automatically rewrites all your injections as lazies. Zach isn't very busy. And that's absolutely that's absolutely something that could be done in Metro that could not be done in any other framework because of the layer that Metro is wired in at.
Not that I have anything concrete, but that could be a candidate as well for a language feature that somehow does like deferred initialization or something.
Like by lazy.
But yeah, without object, such a heavy object penalty, because you're just trading one thing for another. You're now initializing thousands of lazy instances.
Send me a feature request.
You are not initializing thousands of lazies. You're only initializing the lazies that you need immediately. So if you depend on 10,000 things transitively, but 5 things directly, that's 5 lazies. That's a savings of 9,995 lazies.
Good point.
Thank you.
How you doing? First, thanks for the talk. I have a question. You've talked about Metro for obvious reasons. You've talked about Anvil. We've talked about Dagger, but there's been no mention of Hilt. Is there a reason for that, or is it just because these are the projects that you're working on? I just want to know how this relates to what you're actively working on and the future of DI.
I have never used Hilt, so I don't really have any opinions to like share on it one way or the other. Others can answer, but I suspect that in a lot of scenarios like this, it's just because we talk about what we use.
Gotcha.
Yeah, I think the thing about Hilt that is a problem, especially for us on the stage, is that it's definitely an API that has this like really optimized for standing up an app with the standard Google APIs really quickly and providing a nice API for that. Whereas like tools like Metro, tools like Anvil are more general tools that you can, particularly Anvil, you can kind of build whatever you wanted to with Anvil pretty easily. And that's harder with Metro because of the way the compiler integration is, I think. But like it's also more of a generic tool to ease up wiring modules in general. And that's obviously answering the concerns of like bigger code bases. So I don't know. It's something that comes up periodically in the discussion around like something like Metro of how to wire this up more easily. But yeah, I don't know. I don't have a great answer.
Yeah, Hilt is a very Android-specific framework. So you can build a Hilt on top of any of these other systems. And actually, there is a library called Whetstone that does that using Anvil. So.
Okay. Great. Thanks. Appreciate it.
Actually, I was going to say, having done a Hilt to Anvil migration, I agree. Like the Hilt itself is in principle and in usage a lot like Dagger or Anvil itself. And so essentially it's like a specialized subset of, if you have an Android project and you want a Dagger-like thing, Hilt is like the easiest and quickest way to get there initially.
Hey y'all. So far you haven't seemed to shy away from any hot takes. So I have a question that's a bit of a, I don't know, it's kind of putting you on the spot a little bit. So as far as like Kotlin multi-platform projects go, and if you wanted to set up like a greenfield one with dependency injection, it seems like really there's like 3 options. That's Anvil, there's Kotlin inject, and there's Metro. Kotlin inject is done by an individual. Metro is also done by an individual you. I think Anvil, they publish it under like Amazon's namespace, but it's really one person, and I don't know what happens to Anvil if that person decides to leave Amazon. Will they have to fork it because it's under their namespace and stuff? So if you, and hopefully maybe each and every one of you could answer this, if either one of you was starting a greenfield project today with Kotlin multi-platform, which one would you place your bets on?
I think it's worth adding some important flavor to that, which is that Kotlin Inject Anvil is written by the original author of Anvil who moved on to Amazon and wrote this. So it's kind of followed Ralph over to this company.
They also needed to build a multi-platform solution, which he could not use Dagger plus Anvil for because it was only for the JVM. Right. To answer your question, you're right. There's bus factors in consideration. I would actually say that this is the case with probably the vast majority of the open source libraries that you use. If this stage was hit by a bus right now, there'd be a whole lot of libraries that are in trouble. At the end of the day, I can say obviously like I think that Metro is great. You should use it. But it's really a decision that you and your team have to make on your own, because everyone's going to have different constraints, concerns. If a single maintainer is a big concern for you, then maybe Metro is not the right choice, or maybe Kotlin Inject Anvil is not the right choice. If your concerns might not be with an individual maintainer, it may be with using unstable Kotlin compiler APIs. It may be with maybe you don't actually need multi-platform support for the project you're working on, so that's not a consideration at all. It depends on you and your team and whatever you're comfortable with. I think the nice thing is that there are multiple good solutions out there. If you're just working in a plain Java or JVM project, then like Dagger still works really well. If you want everything to be super dynamic, you could even use Juice.
Oh, you want to answer from each of us? Right. I would say like that's an interesting general open source problem, and like the thing to look for when you're working with an open source library is really about open activity and whether people are open to talk with you about the problem. When open source libraries go sideways, it's more for social reasons than it is. The technical reasons contribute, but the social reasons will make that happen a lot more hard than the technical problems will, right? And I think at the scale a lot of Android open source is, like having one strongly opinionated person working on it is helpful, or it's like an easy place to land. If you look at the wider open source system, there's other models for this. People have tackled this problem, but like for something on the scale of, you've spun up Metro in less than a year. It's in the larger open source world, it's not a huge project. So the important thing is that the development is in the open. You can hear Zach talking about his plans. You can say whether you agree or disagree with them and choose something different that makes sense for you, or write something different if you get the bandwidth to do that.
Yeah, I think another thing that's great about Metro is it's all integrated in one solution. And it's all in the open. It's easy for you to contribute if you want. And Zach's been really great at fostering a community, like it's growing. So I think that's the direction that the industry will head in. So that's what I would pick personally. Yeah.
The only thing worse than a single maintainer open source project is a project that's maintained by a giant corporation. They'll like miss their OKRs and they'll be like, you know what, we just don't need that component anymore. Also, I think Flutter is happening at this conference. Nobody mentioned that that's a possible hazard situation for Flutter. It would be a shame if somebody at Google missed their OKRs and Flutter had to shut down. Flutter is dead.
If I could add just one other thing on that. A lot of projects might have a single maintainer, but I would also say that, like to use Metro as an example, I definitely don't work on it alone. There's a ton of people that have been contributing to it, either directly with code or with filing issues or sending reproducer cases or sharing their opinions and feedback. And like all of those add up. It's definitely not like a solo individual project. Yeah.
Thanks.
All right, I apologize to anyone waiting in line, but we're out of time for now. How about everybody gives a round of applause to our panel members here? if you would like to further harass them about dependency injection frameworks or any bugs you have, maybe they can come over here and you can answer some more questions. But thanks everybody for attending.